solve, first of all, having x's within more than one trig function you've already found is somewhat difficult. Okay, so to solve this equation, we should probably try to get these to combine somehow. But the problem is that they cannot combine to be just like sine of 8x. Wouldn't that be nice? That doesn't work. Okay, however...
Can you reduce them?
Huh?
Can you reduce them?
What do you mean by reduce?
Take out the thing. Like, can you take out a 2?
No.
Because whatever is within a trig function has to... Whatever is within a trig function has to stay in the trig function unless it gets freed by a formula.
So when you
Trig
use a
functions trap things.
We have a formula.
What?
So when you use a formula.
Yeah, but we don't have a formula, at least not one that does 6x.
They're from fine.
Wait.
Well, we could use a sine u plus sine v equals 2 sine
Ah,
u plus v over 2 cosine v
that
minus v.
could help us, and here's how that helps us. This one right here turns you into a product. When you have two things multiplied that are equal to something, usually you can solve the problem a little bit easier. Okay, now that's just looking at the tools that you have. So when you're given a problem like solve or verify, get your formula sheet in front of you. I will make it a separate page so you can tear it off if you want.
Oh, thank you.
Okay, and get your formula sheet next to you and look and say, I want to try that one, I want to try that one, I want to try that one. Okay, pick one to start with, the one you think that's most likely to work. And if that doesn't work, go to one of the other ones that you think could be applied to the problem. For example, I look at this problem and I say that angle's doubled, this angle's doubled, maybe I need a double angle formula. I also look at them and I say, I could combine the addition, like Jasmine was pointing out, there's a way to turn addition into multiplication, maybe I want to try that. There's probably others that you can think of that would apply to this situation. Let's try the one that she proposed first. Okay, so let's try to apply this formula right there. I'm not going to rewrite it, trying to make sure that it is on the video as well. There you go. Now you can see it on the video too. This formula right here, let's try to apply that one. All right, so what is u and what is v?
6.
Is it 6 or 6x?
You're right if you combine all your answers. Your u would be 6x. Okay, because we need
2x.
right, and v would be 2x, because u is whatever is inside of the first sine function, and v is whatever is inside the second sine function. Now, technically, they're being added, so it doesn't really matter which one you call u and which one you call v. Ricky.
13 more days till Christmas.
So,
The calendar, I'm sorry.
sine of 6x plus sine of 2x. This whole thing is going to fit into that formula right there. 2 times the sine of u plus v all over 2. So I'm going to take 6x plus 2x all over 2. You can keep writing. You don't have to wait for me. Okay? That gets multiplied by the cosine of u minus v all over 2. So 6x minus 2x all over 2. That whole thing needs to equal 0. Let's simplify a little bit. Okay, so 6x plus 2x gives me
8x.
divided by 2 is going to give me
4x.
4x.
I have
Okay.
a question.
Yeah.
Could you, since you're multiplying by 2, couldn't you just like cross off the 2 since you're dividing by 2?
These 2's with that 2?
Yeah.
No, because these are trapped inside of the trig function.
Okay.
You can divide the 2 that's outside of the trig functions over to the other side. We're going to do that in a minute eventually, probably anyway. Okay? So let's simplify what's within our trig functions. So 2 sine of 4x times the cosine of 6x minus 2x all over 2. What's 6x minus 2x? 4x divided by 2 gives me?
2x.
Okay. that's supposed to equal 0. Now, I have a product that equals 0. Those are my favorite kind of problems, because then I set each one equal to 0 and solve from there. They look really complicated, but they're not that complicated, okay? So you use that every time you solve by factoring. So 2 sine of 4x equals 0, and cosine of 2x equals 0. Okay.
Or can you like point that?
Can you use one of those other formulas? Sure.
For the cosine.
Sure. Not sure it's gonna help you though. The one that transfers into a single squared quantity, either of these might help you. Okay? That top one is just gonna make it worse.
The bottom one?
The bottom one might not make it as bad for the cosine function. The problem is that for the sine function, it's still gonna be multiple trig functions at the same time multiplied together that equal 0. So then I'm just gonna set multiple things equal to 0. Let me show you how to work through it without using that other formula, because you can do it from here without any more formulas per se. Yes, ma'am?
Could you set, the two, like, those two equations, could you set them equal to each other? Since they both equal to
No, because they are not added together, so you do not subtract one to the other side. You would have to divide it to the other side.
then
Can you divide by 2?
Yeah, for the cosine,
For-
could you divide,
No, for the sine.
No, she's seeing this 2 outside, I think. You can't divide this by 2 to cancel out that 2, because again, it's trapped in the trig function. This isn't multiplication. You don't get to just divide to get rid of stuff.
aren't we like trying to find x?
Eventually,
So,
how do you do it?
why don't you divide by 2?
Eventually. You can't do that right now, though. You have to get rid of the cosine function first. So my question here, inverse cosine of 0 asks the question, cosine of what angle or angles equals 0? So where is the cosine function 0?
It would be
Pi over 2 and
3 pi over 2.
3 pi over 2, and actually I could keep going, so let me write down several answers. So 2x, my angles are equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and it would keep going. All right, it keeps going at odd half angle intervals. So it would go all the way around the circle multiple times. Does that make sense? No? Okay. The cosine function is 0 on the y-axis. The angles that are on the y-axis are pi over 2, 3 pi over 2. And then you could keep going around the circle an infinite number of times. Every time you hit the y-axis, your cosine function is 0. Does that make sense? I'm just listing multiple angles here. How do we solve those for x?
You divide by 2.
Now you can divide by 2. But we're going to divide them all by 2. So x equals, divide everything by 2.
So it would be pi over 4.
Pi over 4. 3 pi over 4. 5 pi over 4. 7 pi over 4. And so forth. Divide all your angle measures in 2 and you'll find out what x equals. X in this case is not your angle measures that cause your cosine to be 0. X is half your angle measure that causes your cosine functions to be 0. Yeah.
Can you show us how to do the other side?
Yep. So here you want to first get rid of the 2 outside of the trig function. So divide by 2. 0 divided by 2 is what? 0. Sine of 4x equals 0. On your unit circle, where is the sine function equal to 0?
At pi
So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so forth, right?
Yeah.
All multiples of pi. So my angle measures, which are 4x, are going to equal 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so forth.
Then you divide by 4.
Divide them by 4. X will equal 0 over 4, which is 0. Pi over 4. 2 pi over 4, which is
Pi over 2.
pi over 2. 3 pi over 4. 4 pi over 4, which is pi. 5 pi over 4, and so forth.
So the answers that you get in 2 and the answers that you get in 4, like on the other side, are they both correct?
These duplicate each other. You don't have to list them twice. This answer is more inclusive, so this answer includes all those too. So this is the only list that you need.
Okay.
Does that make sense?
Yeah.
Good. This answer is broader, but it still includes all of those. If it doesn't include, you need to list all possible answers. Okay? Does that make sense?
How many do you have to include? Like, you put dot, dot, dot.
If you have, this is an important question. If you have to be on the interval 0 to 2 pi, you should include all values that are in 0 to 2 pi. If you are not given an interval, the dot, dot, dot is actually okay for right now, okay?
So we don't
We're not
have to
gonna, in
all-
this class, we don't have time to talk about how to write multiples and how to talk about whether you put plus 2 pi or plus pi or whatever, and how to deal with the multiple after
What's the
that.
minimum?
I'll show you individually if you want.
What's the
Okay.
minimum we can put?
Okay.
What's the minimum you can put? You need to start the pattern, so probably 3,
Alright,
and then put dot, dot, dot afterwards.
alright.
That's if you're not on an interval. Okay, good questions.
Thank you.
Do we have time for a verifying one? Do you want a verifying one or no?
No.
You understand the general concepts?
Yeah.
That our homework yesterday? Is that what you're talking about? Is that right?
I was asking a verifying one that uses some of these also.
For Friday.
All right. So the video is going to be up on my big campus.